Okay, Assalamualaikum, good day. So we'll start our learning by logging into our e-learning. As usual, key in your username. Next, go to ESA 112. Scroll to weeks 7. Ketik DMU Kinematics and Photo Studio. Next, download files inside the crank assembly folder, that is base, block, con rod, and crank. Then open Katia V5. Go to mechanical and assembly design. Insert existing component by clicking insert existing icon and click product 1. Go to your folders, click each of the files and click open. As you can see, it is open here. So we need to put all the parts aside. So this is the con rod, while this is the crank, and this is the block, and this is the base. So let's change the colors so that we can differentiate between each part. So I put this crank into orange, con rod into blue, block into green, and lastly base we change into green color. So we have changed the colors of the guidance line assembly. Next, what we need to do is we switch to digital mockup and DMU Kinematics. So in DMU Kinematics you have new workbench. So let's check. We are now in DMU Kinematic workbench. So in this DMU Kinematic workbench we have different tools. So the tool that we will use is, we will not use all, we will use this fixed part tools and also this kinematic joints tools. Okay, so in this kinematic joint tools we have revolute joint, prismatic, and cylindrical joint. For today we will use these three icons only, but you have any icons that you can use. These tools will help you to complete your projects. So I close this one as we have it here. We also have this assembly constraints conversion. This means if you have your assembly constraints in assembly workbench, you can convert it using these tools. But for now I will teach you one by one how to do this using straightforward doing the DMU Kinematics, and in which it is easier. While this is the assembly for simulations for the assembly later. Let's start. So if we start with DMU Kinematic, first thing is we will need to fix a part that is not moving. So let's click fix part. So in this window it asks us to create new mechanism. Click OK, and then if you look into the left bottom screen, select the fixed part. So we need to select a fixed part that is the base. Okay, then second step is we need to create one joints. Okay, so in this case we will select revolute joint to do constraint between this part and this crank. Let's click revolute join. We'll put this aside. So in this revolute join, it says that this is the mechanism one that we will use, and the name is revolute. You can rename it, but I will leave it there. So we click line 1. So line 1 will be available if we hover our mouse on these small cylinders, and this line 1 will be paired to line 2. So line 2 will be here, and then plane, we'll click plane 1 as this plane, because just now we select line 1 as this as the base. So now we click plane 1, and plane 2 should be here. Okay, so for this, it looks at the third section. It is it shows that we can put an angle driven commands. We click angle driven commands and click OK. So now a window showing that the mechanism can be simulated. Click OK. Okay, as we can see, our plane is incorrect. So let's do corrections. Okay, so this plane should not be set as this. Okay, so we can delete it and redo it again, selecting line 1 and line 2 and the plane 1 and plane 2 angle driven. Click OK. So if it's happened to you guys, so we can redo it and get this result. So as we can see that just now we have windows saying that this can be simulated. So let's try this by clicking this icon. This is the simulation icon, mechanism 0.1. Just click and click OK. So we can see that this is there are two windows. First is kinematic simulations, and second is edit simulations. What we can do is we can click and drag to the end and click insert. So if we look, this is the steps. We change the step to the smallest and we click play. So it shows where we slide the slider just now. Okay, this one. Okay, so if we push the slider again to the right and click insert, it will have two steps. Let's play. This reversing is going back to the first point. Okay, if you want to make it turn to be 360s and then stop, let's click this to so that it is continuous. Okay, so we will click pause for now, or let the crank to be on top. Click OK. So this simulation will be under the simulation tab. So next we will assemble this part. So let's click revolute join. So this part to be here. Let's try it. Click both of this line, and then the planes. Click spin and spin, and for now we don't need to click this angle driven. Click OK. So it is now locked. So next we will connect this to this. That is, we'll click revolute join. This surface and this surface. Click OK. So it is now connected there. And lastly, we can do connection between this block to this base. Let's click schematic join. So we'll click this line and this line. Okay, and this surface with this surface. Click OK. So it's showing the mechanism can be simulated. Click OK. So from this we can again we'll click our simulation with mechanism 1, showing it can be moved or rotate. Or we just click simulations mechanism 0.1. Can do another simulation here. Insert in, move it like that to the 360 and click insert. So let's try this. 0.02 and look good. Okay, let's pause this and make it 0.01 so that it is lower. So this is the kinetic movement for the slider crank. So for these tutorials, you need to do it one by one. Firstly, start with the base to be fixed, and then set the crank so that it can be rotated. Next, we need to connect the con rod and block and complete the cycle to the base. So it is connected. So when it is connected, then you can do simulation. Click OK. So in this CATIA, you can actually create a simulation player with videos. This one. Okay, this is the times and parameters, sampling step. Okay, you can you can record the video using screen recorder. It is much more easier compared to if we record with CATIA. If you're using CATIA, it takes more gigs, while Kinematics will use